Hello and welcome to another section in further mathematics. Now I just want us to perform some examples. Let's just go into examples of integration. Let's just go into performing some calculations in integration. But before we do this, I would like us to take a brief review of our previous lesson. Okay, welcome back. Now if you are given this, integrate 2x3 plus 3x squared minus 4, integral is dx. Now to integrate this, remember our law of integration. Remember the law of integration that we usually apply, that says x raised to the power n plus 1 over n plus 1. This is for integration. So always take this as a point of reference. Now our end value here is 3. So we now have 2 raised to the power 3 over 3. That's the integral. Taking this, so n plus 1 is 4. So x raised to the power 3 plus 1 plus 3 x raised to the power 2 plus 1, and we also have 2 plus 1 plus 4 x raised to the power 0 plus 1 all over 0 plus 1 plus c. So this becomes c, 2x raised to the power 4 over 4 plus 3 x3 over 3 plus 4x plus c. And this goes with this. Why this goes here 2 times. So now I have x4 over 2 plus s cubed plus 4x plus c. So with this, the integral of 2x cubed plus 3x squared minus 4dx is equal to this. I'd like us to solve one more again. So let's have integrate 4t raised to the power 3 plus 2t squared plus t squared over 2. So I'd like us to also apply our normal rule of integration. This is t over 2. Now let's apply our normal rule of integration, which is shown here right in front of you. So our n here becomes 3. So integral becomes 4 t raised to the power 3 plus 1 over 3 plus 1 plus 2 t raised to the power 2 plus 1 over 2 plus 1 plus t raised to the power 1 plus 1 over 1 plus 1, that's 1 over 2 is somewhere here. Then we now have 1 plus 1 plus the c value. So with this is now equal to 4x4 over 4 plus 2t raised to the power 3 over 3 plus 1 over 2 t raised to the power 2 over 2 plus c. So we now have 4 going with 4 is now, this t. We now have t raised to the power 4 plus 2t cubed raised to the power over 3 plus c squared over 4, because 2 times 2 here is 4, plus c. So the integral of 4t cubed plus 2t squared plus t over 2 is equal to t raised to the power 4 plus 2t cubed all over 3 plus t squared over 4 plus c. That's for this thing. Then what in a situation whereby we are dealing with bounded integral? Bounded integral. Now what we mean bounded integral is integral of the form plus x minus x So for example, if you are being told to integrate 3x4 with bounds, let me say this is 2 and this is 1. What it simply means is, after integration, substitute the value of 2 in place of x, subtract it in the substitution of the value of 1 in place of x. Now let's try this. You know the integral of 3x raised to the power 4 using our formula that states xn plus 1 over n plus 1. Our n is 4. It's now 3x raised to the power 4 plus 1 all over 4 plus 1. Now we now have 3x raised to the power 5 all over 5. Now this is the integral. But because of the bounded lines 2 and 1, we now substitute x as 2. We now have 3 raised to 2 raised to the power 5 over 5. Then minus the point, you substitute x as 1. 3 raised to the power 1 raised to the power 5 over 5. This is just the meaning of the boundaries. So the higher number, the top minus the one you have at the base, then you get your value. Now 2 raised to the power 5 is what? 2 into 2 is 4, into 3 is 8, into 4 is 16, and into 5 is 32. So we now have 3 times 32 over 5 minus 1 raised to the power 5 is 1. So we now have 3 over 5. And 32 times 3 is 96. So we continue from here. We now have 96 over 5. We now have 96 over 5 minus 3 over 5. So the LCM here is 5. So we have 96 minus 3 over 5, which is equal to 93 all over 5. So if you perform this integration, having these figures, you discover that the integral of 3x raised to the power 4 using 2 and 1 will give us 93 over 5. That will be your answer. Now we can still go into solving another one. Let's create to integrate 3 1, or let's use 2. Let's stop using 1. Let's make use of 2. 3 2 when we have 3x squared dx. Now if you want to integrate it, the integral becomes, remember our rule, n plus 1 over n plus 1. This is the rule. So the integral of this becomes 3x is to the power 2 plus 1, which is 3, over 3. So 3 goes with 3. The integral becomes x is to the power 3. But remember, there are boundaries 3 and 2. So we apply our rule. So we have 3 raised to the power 3 because we are changing x to 3 minus 2 raised to the power 3. 3 raised to the power 3 is 27 minus 2 raised to the power 3 is 8. So our final value here is equal to 19. So which is very, very simple. I know you can solve as much as you can applying this concept. You can as well do this. We have integral of 2, 1 and 4x2. Now with this, if you integrate this, you now have 4x3 over 3. So in solving this, your answer becomes 4 2 raised to the power 3 over 3 minus 4 1 raised to the power 3 over 3. So this is equal to 4 times 8 over 3, because 2 raised to the power 3 is 8, minus 4 over 3. 4 times 8 is what? 32. You now have 32 over 3 minus 4 over 3, and your final answer becomes 32 minus 4 over 3, which is 28 over 3. Now I'd like us to move further into analyzing area under enclosed curved. Enclosed curve. I think this is just the same thing with what we did before now. When talking about that, let me say, for example, a question is being given to you to find the area of an enclosed curve. Let me say this is a curve, and you're being told to calculate the area of this enclosed curve, of the enclosed region. What you just need to do is to calculate its response to the y. This is the x and this is the y axis. Is to get its response to the y and the x axis. Then if the response on the y and the x axis is being gotten, then in calculating it, you just use the integral of such enclosed area in getting your final solution. I would like to say thank you for being part of today's lesson. In order for you to refresh your memory on what we've just discussed, I would like you to go through what we've been doing in this present class. Take the test that will be appearing shortly on your screen. See you and thank you.